All right, so good afternoon, everyone, and welcome to Secure Coding, Storing Secrets in Your Salesforce Instance. I'm Max Feldman. I'm a member of the product security team here at Salesforce. I work on doing security reviews of some of our App Exchange apps. If you've ever called into our office hours, I answer some of those. And I also work on security reviews of a couple internal platform things here at Salesforce.
And my name is Kyle Tobiner. I'm also a product security engineer here at Salesforce, and I specialize in Force.com platform security and architecture.
And so a quick safe harbor statement. This is just to say that you shouldn't base any purchasing decisions or financial decisions off of the content of this presentation or anything future facing. Right now, today we're talking just about things that already exist in the platform, so this shouldn't be an issue, but there it is. And no photos will be required during this presentation. You're welcome to take them, but we're going to put the slides and the demos all online after the talk. So if you're following this session, you'll be able to see links posted to the chatter feed, so you can check out these slides. And we've got some cool demos, too, and we'll have a sign up for those. So you'll be able to sign up for the demos, do them all yourselves as well for more practice, and see the content of all of our presentation, as well as links we've included to additional resources. So if you were thinking of taking pictures, you don't have to worry about that. We'll post all of this online. And with that, we get to our topics. So what we're covering today are secrets. And we'll be covering developer-oriented topics on secret storage for the Salesforce platform. And specific features we'll cover include secrets in custom fields, secrets in encrypted custom fields, secrets in custom settings. And those are the three we'll be talking about. So this should be useful for anyone in the following areas: Salesforce developers, administrators, prospective partners. And something to note, if you think you know all of this, please stick around. We have some trivia questions during the presentation when we'll actually be giving away prizes. So if you get a trivia question right, you'll get a neat hoodie that says, "Keep calm and stay paranoid." We've also got some follow-up prizes for if you answer a question but don't get it quite right. And additionally, if you have any questions during the presentation, please post them to the chatter feed. We have people in the audience who will be following that. So if you have any issues and want to get clarification while we're presenting, just post on the chatter feed, and people will follow up with you. But we will have a Q&A session at the end as well. So what is a secret? The simple definition is that it's a piece of data that requires higher than normal protection. And for our purposes, a secret will be a piece of data that nobody should see, such as a password or an encryption key. And who do we secure secrets from? Attackers, obviously, but also regular users, partners, and administrators, which presents the biggest challenge, because administrators can have much higher privileges than other users. So basically, we're securing our secrets from everyone. Why do we want to do this? We want to prevent theft of data, prevent impersonation, and prevent privilege escalation. And with that, I'll give it over to Kyle to talk about our first segment.
Great. So we're going to talk about storing a secret in a custom field, a regular custom text field. To do this, the steps are pretty simple. You're going to create an object with a custom field to store the secret. You want to make that object private for the org-wide default sharing. You want to remove CRUD and FLS from all profiles. And you only want to access this secret through Apex. And these steps result in the most secure configuration of a custom field. So the pros and cons of this secret storage method. It's very simple. As you just saw, the steps are super easy. You can easily change and update this method because it's just a field. Any admin can update the field properties. CRUD is used to prevent most users from seeing the object, and FLS is used to prevent users from seeing the field itself. Now, the cons of this method are that CRUD is included in many privileged permissions, like modify all data. All your admins have CRUD to whatever object you're storing the secret in. FLS can be updated by admins, also potentially exposing the secret. And anyone who can deploy Apex code can discover the secret. And with that, we're going to demo this. So Max is going to hop over to our demo app, where we have pre-configured a Visualforce page here to store a secret. So right here, what you're seeing is a Visualforce page with an input field where we are going to store the secret on the secret object _ C value _ C field. So Max is going to put a secret in there for us, and he's going to store it. It's a good secret. So right now, we're not reflecting the secret back to the page. It's just obscured to show you that it's there. One thing to note, whenever you're storing a secret with a Visualforce page like this, you want to use a transient Visualforce property so that the secret does not return to the view state. This is something, if you're going through an App Exchange review, you will get flagged for and fail for. So it's just a simple thing to remember. Never return a secret to the view state. Just keep it in the controller once you've stored it. So with that, we've got a secret stored, and I think I want to see if Max can see that secret through the API. So Max, if you could open up Workbench. Workbench here is a tool written by Ryan Brainerd. It's a little browser extension that lets you do API calls, and we're just using it for simplicity. So Max is going to go and look for that secret object. And what we're trying to see here is if just as a system admin, can we see the field? And it's not there. We were looking for secret _ C. So by default, an admin with modifiable data cannot see a field that is not had its FLS configured for his profile. So even modifiable data doesn't give view to FLS. So that's a good thing. But Max, as an admin, there are ways that you can get past this. We mentioned it on a previous slide. So Max, can you demo for us why FLS is not secure against an admin?
Indeed, I can. Also, just so you know, the object is secret object C, and we're looking for the value field.
So we're going into the setup menu. We're going to go to the profile. Max is a system admin, so he's going to pull up the system admin profile right there. And then we're going to find the FLS for the secret object, which is right there. So this is where this sort of secret storage method falls down. Privileged users like Max can go in and edit their FLS, even if they've been configured not to be allowed for their profile. So this is what allows a privileged user like Max to get past this secret storage method, which is why we don't consider custom fields on custom objects the best place to put a secret. So Max, if you could save, and we'll go and see how we get to view this secret. Back to the secret object. The value is there now, and Max is going to query. And we have a result. There's the secret. I am your father. Spoiler. So as you can see, this isn't necessarily the best way to store a secret. And we gave you one way to, let's see, I forget what the next slide is. Oh, yes. So we gave you one way to look at the secret, and that's modify the FLS. We have a trivia here that says, which permissions bypass the FLS protection safeguarding a secret stored in a custom field? Please choose from the following list. So a couple of these are correct, and we want to know if anyone in the audience knows which of these are the correct answers.
And additionally, if you get them correct or if you give it a shot, just come up afterwards during the Q&A session, and we'll hand out your prizes. And
I saw you raise your hand right there first. C and D. You're missing one, the one that we gave away in the demo. But close enough. It's A, C, and D. Modify all data gives you the ability to modify FLS. Customize application and deploy Apex also give you the ability to either modify FLS or deploy some Apex that can view the secret. All right, so now Max is going to go into our next step up in secret storage, storing in an encrypted custom field.
all right, so now we're going to talk about encrypted custom fields. And an encrypted custom field is type text encrypted. So the way you'll use this is you'll create a new field of type text encrypted. You'll choose a mask type, depending on the secret type. You'll configure the FLS of the new field such that 0 profiles have read access. And then you will use Apex to store and access the secret. So a side note is that some may consider FLS to be optional since the contents of the field are obscured. But view encrypted data is a global permission. So any user with this permission could view any public encrypted field and the plain text of that field. So employing FLS results in the most secure iteration of this particular storage method. So the pros of encrypted custom fields are that it's simple. Much like a normal custom field, it's quick to throw up and get working. Encryption is managed by the platform. You don't have to deal with any encryption primitives or algorithms or cryptography. The field is obscured from users without FLS and CRUD being needed. It's also good for compliance purposes. If you need to store data encrypted at rest, this is the good way to go about that. The cons of this are that view encrypted fields is a global profile permission. It's not field specific, and it does reveal the secret. Additionally, anyone who can deploy Apex code can discover the secret. And so with that, let's take it to a demo. So Kyle's going to pull up the encrypted custom field. And basically, this is the same type of Visualforce page we saw previously. You'll store a secret. Apex will handle it. But here, instead of just a custom field, it's an encrypted custom field. So Kyle, go ahead and store a secret for us. He was dead the whole time. And so here's our secret. It's transient. It hasn't been echoed back to the page. But now what we're going to do is see if a system administrator can get to this secret in plain text, as we did in the previous demo. So Kyle, if you could pull up Workbench, and let's see what we can do. So we've got our secret object, underscore, underscore.
And we removed the FLS just to kind of speed this up. But generally, we wouldn't have been able to see this because we would have turned off the FLF for this profile. But you saw how easy it is to get past that in the previous demo.
Yeah. So now we're going to do our query. And here we see that the plain text value is not echoed back. We only see asterisks. So our secret has been obscured. But we're a system administrator. Kyle, is there a way we could get around this?
There is indeed.
But we think it's a good opportunity for a trivia question instead. So we're going to ask you now how we would get around this, basically. So the following list contains possible ways of viewing the contents of encrypted custom fields in plain text. So please tell us which options would show the contents in clear text with no obfuscation, and explain. So we've got stack trace viewer in the developer console, the debug log output from system.debug. We've got a workflow field update copying encrypted field to an unencrypted field, a trigger field update copying encrypted field to an unencrypted field, and a web service that returns the result as a string. So which of these would show the contents in clear text?
And I can mic anyone who wants to answer.
Yes. So he said, would it be B, debug log output from system.debug? Unfortunately, no, that is incorrect. But you can swing by after. We've got the smaller prizes.
And it's a couple of them.
Please don't yell out the answers. Yes? C and D. That's partially correct.
Why C and D? Mm-hmm. OK, so that's correct.
Yeah, so
and
that's
same for D. Are there any other of these that you think would do it? There's one more besides that. E is the correct answer. So web services also return encrypted fields unencrypted. So this is an Apex web service, not just querying the field over the API like we did. If you wrote an Apex web service that returned just the value of the field, it would return unencrypted. So you can come up for a hoodie later.
Or at the Q&A session. Yeah. And so now what we're going to do is show you a demo of one of the ways to do this using a trigger field update. So yeah, as we saw, it's the last three.
All right.
So Kyle's going to take us back to this demo, and what we're going to do now is create a trigger for the account object. And what we've got here in this trigger is before inserting an account, so on the creation of an account, what we'll do is just have a string that says, here's the list of secrets. Then we get every encrypted value from all our secret objects, and we append the plain text values to this string. So it will say, here's the list of secrets, and then plain text values of any of our secrets in this org. And then what we see here is we're going to update the account description with that string. So what we should see happen is when we create an account, the description will be filled in with plain text values of all of these secrets. So Kyle, if you could create an account for us.
Sure. And just to point out, the encrypted field is on the secret object, but our trigger is actually on the account object. It doesn't actually matter where the location of your trigger. It's just Apex itself has this ability. So let's go.
What was that?
Creating a formula field, would it do the same thing?
A formula field? No.
I don't think so.
So workflow and triggers will, but not a formula field. So what we've done here is we had an empty description of the account right before we saved it, and then when we saved it, the Apex going on in the background said, here's the list of secrets, and then he was dead the whole time, our secret has been revealed in plain text.
And I kind of sped through that. I could do that again. It's pretty basic.
So we can, yeah, so we'll just do this one more time. We'll create a new account. And so any account name doesn't matter. Can you show the description, Kyle?
Yeah.
Yeah, so we see here our description starts as blank, and then our trigger fires, and it fills in the description with the plain text. So here's how we've shown how to use just a trigger object to get around, or how to use a trigger to get around being able to, not being able to view encrypted data.
So anyone who can deploy Apex or create a workflow could potentially leak a secret for themselves if they wanted to.
And so with that, we'll hand it back to Kyle.
All right, so we've been leading up to this one. This is obviously our preferred secret storage method. We're saving it for last. These are manage protected custom settings. So first step, managed, create a managed package. If you're a partner, this is super easy because you probably already have a managed package. If you're not a partner, you can still create a managed package. Managed packages don't have to go onto the App Exchange to be created. So this is something any developer can do. But there is some overhead, which is a little bit unfortunate. But anyone can do this. Next step, inside the managed package, you create a protected custom setting. Then you create a Visualforce page inside the package to create and update the secret. Again, transient string, don't return the secret to the view state. And then once you have all those three things in place, you can access and use the secret inside the managed package. And we're going to go into this a little more in a second here. So in case none of you or some of you are not familiar with custom settings are stripped down S objects. They don't have FLS, they don't have CRUD, but they are exposed to the application cache, making them relatively efficient to access from Apex. And the big difference in a custom setting is protected versus unprotected, managed versus unmanaged. The protected flag on a custom setting does one thing. When you check that flag, it says that this custom setting can only be accessed from the namespace that it exists in. So if you have a custom setting, not in a managed package, just in your org, you've just created it, and you set it as protected, that actually doesn't do anything because the users who are going to view that custom setting are in the same namespace as the custom setting. You need to actually put the custom setting in a different namespace, and you do that with a managed package. So what does this mean? Managed protected custom settings offer security benefits that normal custom settings do not, because they are in a different namespace. Unmanaged protected custom settings are worse than regular S objects for secret storing because they lack FLS and CRUD. A portal user with API access can see a custom setting that is protected in the local namespace. So avoid custom settings, protected or otherwise, in the local namespace for secrets. So here's a little diagram of everything I just said, just to kind of make it clear. We got two custom settings, the green diamonds. One's in a managed package, one's not in a managed package. You can see the people in the local Salesforce instance, those would be your users. They can access that protected custom setting either through the API or if they have the view setup menu. And then any Apex in the local namespace. That's okay. And then inside the managed package over there, we've got another protected custom setting. Only the Apex and the users in the local namespace, just the regular users, they can't get to that. Only Apex inside the managed package can access that custom setting. So what are the pros of this method? The secret is only available to Apex code within the managed package. And if you need to scale, custom settings don't have a huge amount of storage space. You can store encryption keys instead of secrets to scale. And then if you need to encrypt things outside of the managed package, you can do that with the encryption key that's in the managed package. The cons of this obviously are it requires a managed package. If you're a partner, you skip right over that con. But if you're not, there is some overhead to creating it. But once you've done it once, it becomes relatively simple. Also, there's a note here. The methods inside the managed package must be well coded, sort of well thought out to prevent secret exposure. And I'll show you an example of that shortly. So let's demo this. Max, if you can slip over to our demo. So here we have another Visualforce page. It looks exactly like the previous two Visualforce pages, except in that little demo area right there, that's actually a Visualforce component inside the managed package that we created for this demo. So that's not in the local namespace, but it's displayed on a Visualforce page that is in the local namespace. And Max is going to store a secret there exactly the same as we did before. That's not a secret. Great. So the secret is stored exactly the same as we did before, except now it's inside that managed protected custom setting in our managed package. So Max, if you could hop over to Workbench again, let's just do the same thing we did for the other two. Let's see if we can see that custom setting. Oh, Max, what's the name of the custom setting? I don't think we mentioned that.
Apologies.
That would help. So this should have a namespace, so it's going to be a little longer. It is secure storage. That is the namespace of our managed package. And then secret _ C and value _ C for the secret. So that's what we're looking for in Workbench, secure storage.
So here we see that we're not seeing it. We don't see secure storage.
And obviously, this is sort of expected. This managed package is in, or this protected custom setting is in the managed package. We shouldn't see it, and we don't. So maybe, Max, if you can go to the metadata for this custom setting, let's just show what it looks like from there. So here, installed packages, you can see our managed package right there, secure secret storage, or secure storage demo. View components. Actually, it doesn't even show up here. Managed packages and protected custom settings that are in them don't show up anywhere. You shouldn't be able to see this at all. It is just deeply ingrained inside that managed package. Nothing in the external local namespace can get to it at all. So maybe one last thing we can try is doing the trigger like we did before. Can the trigger, which is Apex, get to the managed package protected custom setting? It's kind of a lot to say, protected custom setting, every time.
So this is the same trigger that we had previously, except we're trying to get our secure storage.
And you can see there on line 4, it says secure storage _ secret _ C. We're using the getAll.values to get all of the values out of that custom setting. And let's go ahead and save. Boom. No access to entity. So this proves that it exists. We just don't have access to it because we're in the wrong namespace. So this is about as secure as it gets for a secret on the Salesforce platform. Managed protected custom setting. Nothing is getting to this unless it's inside that managed package. Great. So one more diagram just to show you, because it's easier to see this on a diagram than it is to see it in a demo. This is sort of the ideal scenario for using that secret. Let's say it's a password to an external web service. We'll have the diamond there. That's our managed protected custom setting. It's inside the managed package, and we access that, as you saw in the demo, through a component and a controller with a transient string, and we put that component on a Visualforce page in the local namespace. So that's how you set the secret. Then to use the secret, in the top right corner, it says Apex Web Service. We're going to grab the secret out of that custom setting and send it out to the web service using it for authentication or whatever we're using it for. If we need to invoke that call out from the local namespace, you can have a global method in the managed package that is accessible to the external namespace. So we have a global invoker, and we can call that from a scheduled job, a trigger, developer console. There's a bunch of different ways to call that. You just have to make sure that you're only calling an invoker, not returning the secret out of the managed package namespace, because the whole point was to keep the secret in the namespace of the managed package.
And just a quick interjection, we've seen a couple of people taking pictures. If you walked in late, we're going to post all these slides online as well as the demos. So if you were taking pictures to save these slides, don't worry, and these will be publicly available, so you can just download all of them.
So, trivia question. And this question deals with sort of the how can you screw up storing a secret in a managed protected custom setting. Here we have a global method called basic auth callout. It takes as a parameter a string called URL. It makes an HTTP request, sets the endpoint as that URL, grabs the password out of that custom setting, puts it in an authorization header, and then sends the call out. Now, this is an insecure piece of code. And can anyone in the audience tell me why this is insecure? Back there? Perfect, yes. So it's global. You can access this from the external namespace, and it takes a URL. So what if I put in a URL that's attacker.com? This method would then forward that secret out to my external web service. And this is sort of getting back to that point. If you have to make sure when you do put your secret in your managed protected custom setting, you also put the functionality that uses the secret inside the custom setting. Because if there's any information that comes from the local namespace it's possible that that secret could get leaked. So Max, to the better version of this. The better version of this has the endpoint already in there on line 3, where we set the endpoint to api.somewhere.com. If you wanted to get a little more complex, you could actually put another field on the Manage Protected Custom setting that has the URL where the secret should be used, so that the secret and the URL are combined together and they always go together, so that if there's a, you can't use it with a different URL. It just grabs the URL from the custom setting from which it's been saved. Yes, so let's do a little recap. Custom fields. The pro is that they're simple. Oh, actually, I'm flipping over to Max. I'm sorry. I'm
no
running away
worries.
with it.
Stealing my thunder. So yeah, we're going to do a recap of the 3 major ways of storing secrets that we talked about. So the first one we covered was, like Kyle said, a custom field. So the pros of this are that it's simple, or the main pro is that it's simple. The FLS and CRUD will prevent most user access. However, the con is that it can be bypassed by users with elevated permissions, such as modify all data and author apex. And what we want to always keep in mind is that we secure secrets from everyone. We're not, even people who have higher permissions should not be able to view our secrets. So custom fields work well with sensitive data that does not have encryption requirements. The second thing we discussed was the encrypted custom field. And the good parts about encrypted custom fields are that it's more secure than basic custom fields, but it's still simple to use. It prevents most user access, and it does support masking options. The con here is that it can be bypassed by users with elevated permissions, so modify all data, author apex. This works well with sensitive data with masking or encryption requirements. So if you've got to meet some standards or requirements where your data is encrypted at rest, encrypted custom fields will do this, and they'll spare you a ton of trouble of having to deal with cryptography and implementing that on your own, which is always a bad idea. And so lastly, we talked about our most secure method, which was manage protected custom settings, and this is our secret storage best practice. So the pro here is that it's the most secure option. It protects against users with elevated permissions, including modify all data. And so we saw that even though if you can author apex and get around all these others, if you've got very high permissions, you can't for a manage protected custom setting. The con is that it requires a managed package, so there's a bit more overhead there. And additionally, it requires careful attention to code. So even if you're securely storing your secrets, you have to be careful when you're passing them around, or if you're making callouts, things like that. You have to be kind of vigilant about this and make sure that you're not being insecure with your handling of this secret after it's stored. And this works well with passwords, OAuth tokens, and encryption keys. And it will also allow you to kind of scale encryption. So if you just store your encryption key, you can keep your encrypted data somewhere else and only store your key in the manage protected custom setting, but if you're concerned about data usage in your managed package, then you can have your encrypted data stored elsewhere. And so we've got a bunch of additional resources for you guys. And once again, these slides will be online, so all of these links will be online as well. But we have secure coding guidelines. We also have intro to managed packages. And additionally, we have the Salesforce Stack Exchange and the security tag and the developer.salesforce.com security forum. So both of these are good places to ask questions. And what we do is we will check them. We'll try and be on top of that and answer any questions that go unresolved and respond with kind of the official best way to be secure for some of these concerns. We also have security office hours. So if you're a partner, you may have already done these before, but you can call in. I'll answer some of those. We have other people on the team here who will as well. And additionally, we have a security implementation guide. So this has a lot of general security topics. So if you're trying to implement something securely, this will cover it. So something like IP login ranges, all this other stuff will be covered in our security implementation guide. And so the slides and demo will be available at this link. You can also follow Kyle at Kyle on Twitter, and he'll be tweeting this data and this information as well. And if you want to play with a demo code, we have a demo sign up. So as you saw in our demos, there was a lot of text on some of those pages, and we didn't go through the text, but basically that text is explaining how to do those demos, and it's explaining what goes on in the background. So if you want to try them again, or if you want to see kind of a couple other things available to you in those demos, it's all in there. So you can sign up. It'll spin up an org for you, and you can do all the demos we've done here. Additionally, if you were at our earlier talk, it's kind of the same thing. You can do any of the demos from CRUD FLS and sharing, and any of the demos from secure storage of secrets.
Yeah, and one thing to mention really quick, I didn't mention this in the last talk. On the home page inside the demo, if you sign up for it, there's a feedback form here. This goes directly to us. And if you like these style of demos, we're thinking about doing some more stuff like this publicly. So give us some feedback. Let us know what you think of the demos, because we put a lot of time into developing them, hoping to educate whoever needs help.
Yeah, and if you have any suggestions for improvements, we're happy to hear those as well. We want these to be the most useful possible thing that they can be. And so additionally, we have some more secure development sessions throughout Dreamforce. So we had ours earlier this morning. Later on today, we've got building secure mobile apps. Later in the week, there's protect your data against malicious scripts, secure coding, external app integration, and secure coding SSL, SOAP, and REST. So if you're interested in any security topics, all of these are going to be great. We've got some very talented colleagues who are giving interesting talks. They're worth checking out. And a couple announcements. We have the Force.com code scanner now supporting Salesforce 1 and JavaScript. So if you've checked that out, you can now scan more languages. And so we've got a bit.ly link for that. And additionally, we have the Chimera web app scanner. So that's got alpha nominations open, and you can apply if you're a partner at that URL. And finally, we have live security office hours available in the partner zone over in the West End. So I'll be there later this week. Some of the people who are in here on the product security team will be there as well. So if you have any questions about security, about any of these talks, about security topics, about anything, feel free to stop by. You're welcome to just stop by and say hi as well. We're always happy to meet other people who love Salesforce as much as we do. And yeah, so with that, we'll take it to a Q&A. For the Q&A, if you could ask questions at the mics, that would be great, because we want everyone to hear the questions, and we will answer them. And if you answered a question or got it right or wrong, come up and we can give you your prizes too. Thank you.
Thank you.
Yeah,
What is the overhead on a managed package?
that's a great question.
You just have to spin up a new org, set up a namespace. It's basically just an org with some credentials that you have to create, and then you have to install the package in whatever target org you have. So the overhead is like one additional org to deploy to, but if you're already using a couple sandboxes, it's really not that much overhead.
And a follow-up question. Would a developer edition org be a wise or a poor choice to use for a separate org?
Developer edition org is actually just a fine choice. It doesn't expire, and you don't need a lot of storage space or anything when you're developing in it, obviously, because you're just going to install that package somewhere else. So I think most packages that permit you to create a namespace have to be developer orgs anyway. So it's a perfect choice. Cool. Any other questions? No? Well, thank you, everybody.
Yeah, if you have questions, feel free to ask, or you can come up here too. We're happy to talk to you. And if you want your prizes, come on up. And we've got shirts and cups.
Thank you.